Welcome to Click Academic. The last time we talked about limits and decided limits. So this is just a furthering of that theory. So this time we are going to talk about existence of a limit, and we are going to use this for further learning. Okay, for a limit to exist, we talked about sided limits before. So if f of x is a function of real variables, then the limit of f of x exists at a, that's as x tends to a. That limit exists only if the left-sided limit is equal to the right-sided limit. So that being said, this is only when a limit exists. This notation stands for if and only if, meaning this is exclusive to this condition. When this condition is not satisfied, that limit does not exist. So that being said, we'll move on to continuity of a limit. So a function f of x is said to be continuous at a point. Let's call that point a, x equals to a. If these conditions are satisfied, f of a is defined, and we've learned how to substitute constants into functions. F of a is defined. The limit as x tends to a of f of x exists. That's the left-sided is equal to the right-sided, or we can just substitute directly also. And f of x, the limit as x tends to a of f of x is the same as f of a. These three conditions have to be satisfied for a function to be said to be continuous at a point a. So continuity also has algebraic properties. So if we have two functions, let's say f of x and g of x, that are continuous at a point x naught, then the first says f of x plus or minus g of x, meaning whether it's addition or subtraction, the function that we get from this algebraic operation is going to be continuous at x naught also. Same for multiplication. This is also continuous at x naught. Same for division, but the division has a condition, meaning g of x should not be equal to 0, because we try to avoid multiplication and division by 0 when we are talking about limits. We've said this before also. So for the last condition, it says k of f of x, meaning if for constant that is multiplying f of x is also continuous at x naught for every constant k. So these are algebraic properties of a continuous function. We are going to be using them later on when we try to show how functions are continuous, they are discontinuous and all that. So that is that.